Okay, now we start our exercise 2.3. Before we move on exercise 2.3, we write our theorems again. So our first one theorem was derivative of any constant function, say c, is equal to 0. The second one was derivative of any function multiplied by a constant number, that was constant will be unaffected, derivative will be applied only on function, so d by dx of fx. Third one was our power rule or power theorem, derivative of xn, that was n x n minus 1. By using this third one, we can derive our some results. If we want to differentiate simple x, then that will become, here power is 1, so this will become 1 into x raised to the power 1 minus 1. So that will be 1 into x raised to the power 0. So this is also 1. So 1 into 1 is equal to 1. So derivative of x is equal to 1. And similarly, we can differentiate another very common function, square root of x. Here that is equal to d by dx x raised to the power 1 by 2. By using power formula, 1 by 2 x 1 by 2 minus 1. So this will become 1 by 2 x raised to the power minus 1 by 2. And that can be written as 1 by 2 x raised to the power 1 by 2. And this is actually 1 by 2 under root x. So whenever we differentiate under root x, the final result is 1 by 2 into under root x. So now we generalize these two results by writing it like d by dx fx raised to the power n. So this will become, by using power result or power theorem, n f of x raised to the power n minus 1, and again differentiate this function. A very important explanation: if we want to differentiate a function containing power n, so that will be differentiate in this way: power n, function, power n minus 1, and again derivative will apply on this function. So this will become d by dx of fx. And similarly, if we want to differentiate d by dx of any function f of x under square root, so this will become 1 by 2 under root f of x and d by dx of fx. So these two are generalized result of power rule actually, but this is very common use of these two functions: a function containing power n and a function containing power 1 by 2, or you can say under root f of x. Without using some steps of power rule, we directly move to this step 1 by 2 under root f of x and then derivative of fx. So this one is explanation of power rule. Our next theorem was sum or difference result d by dx fx plus or minus g of x. Derivative will apply on both of these functions separately. So this will become d by dx f of x plus or minus d by dx g of x. And similarly, fifth theorem was d by dx fx into g of x. If we want to differentiate a function which is actually in product form, so that will become f of x and d by dx g of x plus g of x d by dx f of x. So in simple words, you can say derivative will apply one by one and other will remain same. F of x will remain same, the derivative will apply on g of x, and then derivative will apply on f of x and g of x will remain same. This is called product rule. And the sixth and last one was d by dx f of x over g of x. The quotient rule actually. So this is equal to, in a simple way we can say, in denominator g of x whole square, g of x will remain same, derivative will apply d by dx on f of x minus f of x will remain same and derivative will apply on g of x. So d by dx of g of x. So these are our 6 theorems or 6 results